Hello everyone, a very warm welcome to this video. In this video, we are going to talk about what exactly is big data. Now, before we jump into big data, let's talk about why does it deserve your attention. As per IDC, big data market would be $24 billion by end of next year. By end of this year, big data would have 4.4 million new jobs. And as of this very moment, United States alone is facing a shortage of 200,000 big data professionals. So the point is, irrespective of the stream of profession you belong to, there is something or the other for you to look forward to when it comes to big data. If you're an administrator, you have a big data administrator role. If you are a developer, you have big data developer role. If you're a data analyst, you have big data analyst role. If you're a statistician, you have data scientist role. And there are a lot of other positions open when it comes to evangelizing the whole technology. So irrespective of the stream of profession you are, there is incredible amount of opportunities that this stream has for you. So now let's talk about what exactly is big data. Now, in the most simplistic terms, big data is the amount of data that cannot fit in a single physical server. Big data is the amount of data that is beyond the processing and storage ability of a single physical machine. That's the most important dimension of big data. There are two more dimensions to big data, second being variety and third being velocity. So volume being first, variety is you have data coming from multiple sources and multiple formats. So far we've always seen data in terms of rows and columns, but what big data talks about is data can come from any source and any format. And third is velocity. Data being big is one side of the problem, but new data is also getting generated really fast. So that's velocity. So volume, variety and velocity, these are the most important three dimensions of big data. A quick reiteration. So volume, for data to be qualified as big data, the volume has to be massive. Data typically comes from multiple sources, that's variety, and data comes to you at a great speed, that is velocity. So volume, variety and velocity. Now, these three terms would appear to be buzzwords, but they are not buzzwords. These are the factors that define if big data is right for you or not, or big data project should be implemented or not. So let's look at how does these three factors help you deciding on is big data right for you or not. So the question that we are trying to answer with the help of volume, velocity and variety is, so let's take a scenario. We have a data warehouse, can cater up to 10 terabytes. Today has 2 terabyte and per week we get 1 GB. So we have a data warehouse that can cater up to 10 terabytes of storage. As of today, we have 2 terabytes and per week we are adding 1 GB. So the question is, should we consider big data? Well, the answer is a clear no. Let's understand why. Now, you can cater up to 10 terabytes of storage. As of today, you have 2 terabytes and per week you are adding 1 gig. That means in a year you are adding 52 GB. Now at 52 GB per year, you are going to take 120 years to fill this 8 terabytes which is remaining. So this is one of the case where you have volume which is not so big and literally no velocity. And in this case, you would say that big data is something not for us. Now let's take exactly same scenario and change a few things. We have a DW that can cater up to 10 terabytes. Today we have 2 terabytes. Per week we are getting 1 terabyte. Should we consider big data? Well, the answer is an absolute yes. So the point is that within 8 weeks we are going to run out of space and we'll have to find a better way of doing things. So this is a clear example where you know how volume and velocity and variety would play together and help you decide if big data is right for you or not right for you. All right. Now, now that we are clear with big data, so now that we are very clear with whether big data is right for me or not, let's talk about a few logical things that may come in your mind. First is, well, looks like big data is clear, but how does this data look like? The point is, there is no defined set as to how big data looks like. Big data can look anything like an RFID sensor file. You can have data from web transactions. You can have data from web logs, can be from anywhere. What do we do with this data? Analyze it. But the tough question is, I have been in business for 100 years and I've been profitable. I have everything running on my database. Why should I really take pain and invest into this whole technology and analyze data that's not really structured? Well, it's in this huge heap of data the golden nuggets of vital information stay. Analyzing this data would really, really take you ahead than your competition. Let's take a simple example. Now, Amazon is a website where people purchase stuff, but Amazon makes 35% of its money just by recommending products. So you come to buy something and Amazon shows you people who bought this also bought that. Based on this simple recommendation, they make 35% of their revenue. Technically, that means 35% of money is made by selling products that customer never came to buy. That's really, really great. Take example of Facebook. Based on what you do, on the right side you see the ads change. If you go for a road trip, you suddenly see ads that are pertaining to that. If you have a new member to your family, you suddenly have ads pertaining to, let's say, baby products. That's the real idea. So overall, the idea of big data is to take all the data that we have, analyze it, and improve the experience around basically e-commerce, around fraud detection, around aeronautical engineering. There are like every field has a lot of data, and here we are to analyze that particular data. Can we have some use cases of analyzing data? We've already seen use cases of Amazon and Facebook. Now, this is a course that really is from the engineering perspective. We are not in this course discussing about what Amazon or Facebook is doing. Our real intention of this course is how can even I do it? So this is more of an engineering side of things as to what if I want to implement this whole technology in my organization, how can I do it? So the real question is, well, even we have a lot of data, how can such huge data be analyzed? Well, as the volume is beyond the storage and processing ability of a single physical machine, some distributed way would have to be used. We'll have to use some distributed way. Now, as soon as we talk of distributed systems, the first thing you say is wait. Distributed systems like MPI and MPP have been around for more than a decade. So do you even need to take this course further, and does the world really need another distributed system? So distributed systems are old, and why are we even discussing that in this course, and why did somebody create a new distributed system? So let's understand that. So before big data or Hadoop, the previous generation distributed system looked like you have a SAN and you have app servers. So you have a SAN, let's say, that stores 10 terabytes of data, and you have 10 app servers. You deploy your Java code on all 10 servers, and each server will read 1 terabyte of data and process it. So the entire flow was programs run on each app server, all the data was on SAN. Before execution, each server writes output to SAN, and after execution, each server writes output to SAN. Now this approach had some problems. The biggest problem in this approach was there was incredible amount of dependency on the network. Scaling up and scaling down was not a smooth process. Partial failures were difficult to handle. A lot of processing power was spent on transporting data, and data synchronization was required. So the previous generation system had these issues, and that's where we decided to go for this new system called as Hadoop. So just to really put everything in perspective, a single diagram should summarize the whole thing. So let's talk about evolution of data analysis. So episode 1 of data analysis was more CPU and more RAM. So we wanted more computing power, and what we did is we kept on increasing the capacity on a single server. Then we realized that it's not possible to always scale your servers that way. You can't have a machine with, let's say, infinite RAM. There will be a limit to how much RAM you can have on a single machine. And that's where, to get more computing power, we went for distributed computing and central storage. So while we realized that on a single machine we cannot keep on adding resources, we went with distributed computing and central storage. So that's episode 2. You have SAN and you have machines. On the runtime, the data will be read, processed, and you write the output. Okay. Now this was episode 2 of distributed computing. In this, network was the biggest bottleneck, but more importantly, data was not huge. Now post 2005, something really changed. Every user was basically creating content on the web. Before 2005, majorly people were consuming content on the internet. Post 2005, we started creating content. We upload photographs, we go to Facebook, we go to YouTube, and we add a lot of data. Now post episode 2, the problem was that even a single SAN will not fit for us. And that's where we went with episode 3, where we had distributed computing and distributed storage. So you had a master and you had slaves. So each machine had its own computing and its own storage. So a centralized master was managing the whole thing, and everybody was just reporting. And this system is called as Hadoop. So a quick summary of this whole thing would be that we always wanted more computing power, and it was not always feasible that we will increase it vertically, so we decided to go horizontally. So in our zest of going horizontal, the episode 2 was we had central storage and we had distributed processing. When central storage was not enough, we went for episode 3, where we distributed the storage and distributed the processing. And that exactly is Hadoop. Now this is the basis of our course, and we will now look at how this Hadoop really works in the next video. Thanks for watching this video. See you in the next video.